Hi everyone, we will continue the fourth model, Interactive Systems and MVC Architecture. So we had discussed in the previous videos the implementation of model classes, implementation of view classes, the implementation of controller classes. The next we will discuss the driver program and critique of our design and some more detailed discussion of view classes. So we have started in the previous videos, that is view classes, public, void, paint component method. So we had discussed about in the view class implementation. So now here we are going to just discuss the continuation code of that one. That is the drawing panel, as we have taken class, our main classes, which overrides the method is paint component method, which we have called the screen is to be updated. So here public void the paint method graphics G model set, this new swing package will be taken get instance. So the paint tree component method paint component of G. So the set color of blue, whatever red, whatever we have taken. So enumeration of model dot get item. So while condition will be taken here, enumeration dot has more element. So another thing we have taken in the item, next item list should be rendered. So G dot get color, the color should be red. Enumeration model get selected item. So while enumeration uh, has more elements, the item of that enumeration should be taken it as the rendering the item. So next, so it should be taken a drawing panel classes. The J panel overrides the add mouse listener. So that we add method we have taken here. Add key listener, add mouse listener, and add focus listener methods will be added into this view classes. So this is to ensure that there is at most one listener of each type of the event on the drawing panel. So that we could take it as a Java code here, private mouse listener of the current mouse listener, public void add mouse listener. So the mouse listener will take a remove mouse listener and current mouse listener, current mouse listener, new listener. So that we have to take a super dot add mouse listener of the new listener class we have method we have taken. So here what we are say that similarly we ensure that there is a one just a listener of event which are related to that keyword we have taken is one of the complicated ones here label button, so which is also responsible for handling the creation of the request. So whenever the request from the client, so this J label Java, that is the label button, which is always responsible to handle this type of request of the particular part. So here one of the constructor of most button class get reference in the view class. One should be we need to take it as the selected. What is that one? Access of the drawing panel get selected. So that we could take it as the mouse listener event. So next we say that we are going to continue this driver program. So as I said that driver and last one is what is our critique the design or our design in the implementation phase. So the driver program here we say that the driver program which is the set what we are going to set up the particular model in our actual implementation. The controller is independent of the user interface technology, so it can be with any view. So that is the goal. So here the view itself uses the swing package is the observer of the model. So finally this code says that driver program can be how we are going to set the particular in the driver program in the model class. So this is the class we have taken, public class drawing or drawing program. This is the main class we have taken. Here that void main, okay. Model is equal to new model, controller is the set model we have taken, controller is equal to new controller. Similarly, view controller of the object we have taken as a controller, view dot set model, and view is equal to view new model as a add observer. Model will be taken it as a subclasses, add observer, view should be in the show part. So the next we would discuss about a critique of our design. So far, whatever we have designed, when the implementation of all our design classes, MVC subclasses like implementation of model class, controller class, and view class. So what we found, what is our criticality of in our design? So actually here the partial of the view and model are quite robust. We say that compared to all three models. So here design of the view and model are quite, controller not too much robust. So we have examined some of the issues taken case and earlier the implementation takes them into consideration. So here the controller which appears to be a quite straightforward, simply we need to add we say that method to handle all the type of the operation. So now let us see how the design stand up to the task of adding new operations, say to draw a polygon. So we had already discussed about draw a line, draw a label, draw a circle. So whatever we have just discussed, now what is the criticality or critique of our design with the help of this polygon explanation. Let us see how design stand up these the polygons. The first point wise we need to discuss here. First point, so we need to provide a new button which informs the user that the new operations which are available. So these operations which are readily available, we have to inform that in the form of new button. So what it does here, we also should actually we should create actually mouse handler to handle the mouse click of the event. So here whenever these changes are relatively which obviously and clearly unavoidable, we say that even then note that the most of the classes in the view are, so view are left unchanged, so which remains unchanged. We had already discussed about this. So next point here, the model is not affected by adding new type of the items, operations, or new user interfaces. So that we need to take it into consideration. Whatever the type of the model, which is always not affected by the any kind of the we had discussed about list of items, selected item, all the remove item, so all the details, so this is not affected. So that is the point we need to take it as a our consideration. So the next third point is the user interface context interface, which doesn't have to be necessarily extended when a new kind of items are added. So here we say that new kind of items are added. So we say this is the already we have discussed in the previous what type of the user interface catering to the multiple user interface, that is the user interface context and along with diagrammatical representation. So now the fourth method is the controller should have new method such as make polygon and add point to polygon. So actually here, which is not clear that this message which changes not consequences of the basic law of origin. So here, for instance, it might possible to replace the method make line or make circle by make polygon, or polygon adding point to be need to be taken. So say make shape. So actually thus one drawback to our approach here, uh, we need to change the controller class in every type. So new operations are added even if we change the way things are implemented. So in addition, the controller has all the implementation in one class, which makes things complicated. So more tricky problem here, implementation of undo, which are going to discuss in the next slide. So that could be taken it as the more point to be consideration here when an undo is requested, the element from the top of the stack is swapped. So this element has to be coded to find out how or what last operation was did. So that we need to take it. So this is all what we are going to find out. There are some point toys critical or critique of our design. So that we would discuss in the next slide or coming section, that is the implementation of the undo operation, how we are going to tackle these issues, along with what are the even drawback of this implementation of issue, employ the command pattern undo ing and operations. There is a sequence diagram, and there is a command class sequence diagram for adding line in that one. Status of the stack of collection in the model, status of the stack in the collection of the model after undo ing implementation, undo manager. So this and all are drawing, handling the input, drawing incomplete items, and last adding the new feature. We have to discuss example of architectural pattern. So now in the next slide we are going to discuss. So next we are going to discuss implementing the undo operation. So we have discussed about critique of our design, how it is going to handle. So now we will see this in the context implementing the undo operations. Before that, so we need to discuss a few issues to be highlighted. So the first one, we'll discuss one by one. Single level undo versus multiple level undo. So this is the point how we can take into the consideration. A simple actually a form of undo is when only one operations, for example, most recent one. So in example, what we are typing in the Word or in the Paint, so whatever that most recent one we are calling it as an undo. So this can be undone. So this is actually relatively easy because most recently done, since we can afford to simply clone the model before each operations actually and restore the clone to undo. So this is the thing, single level undo versus multiple level undo. So in case of multiple undo, so bit might be different to single level undo. So next here undo and redo are unlike the other operations. So let us discuss here, if an undo operation is treated the same as any other operations, actually then two successive undo operations cancel each other out. So The second undo reverse actually the effect of the first undo, and is we can call it as a redo. This is comes under two successive undo operations of any previous two statement, whatever it is. So that we can take it as a redo operation. The undo, and we say that in the bracket we say that redo. The operations must therefore we have a special status like meta operations if several operations must be undone. Next point, not all the things are undoable. So this we should be considered very carefully, because this can happen for two reasons. Some operations like a print file are irreversible. So actually entire file is not possible, because there are the complete contents which comes under the file. Similarly, other operations like save to disk, which may not be worth trouble to undo due to the overhead of the nodes. This is also not possible. Another point is blocking for the undo or redo operations. So it is easy to see that on control, undo and redo can result in meaningless request. So in general, it is safer to block redo whenever the new command which is executed. So for example, here a more severe problem arise with a create rectangle, color rectangle, blue, or delete redo. So this will come to know that there are a lot of issues will be highlighted. So last one is a solution should be efficient. So this constraint rule out Navy solutions like saving the model to disk after each operation. So regarding this, we should keep in our mind a simple scheme of implementing undo could be something like this. Create a stack, we'll see in the next slide. Okay, create a stack for storing the hierarchy of the operations. So next one is for each operations we should define a data set or data class that will store the information necessary for undo operations. Implement code so that whenever any operation is carried out, the relevant information is packed into the data object which are pushed onto the stack. And the fourth one is implement undo method, the controller that simply pop up the stack, it decode the pop up data and invoke the appropriate method to extract respective or a particular information and the task perform the task of undoing operation. So these are the issues we should actually keep in our mind. We simply see what is that implementing undo. We should follow these few points. So next we say that, so one uh, uh, obvious approach for implementing this is to define a class, for example stack object, so that which stores each object with an identifying string. Here, public class stack object will be taken class stack object, and the string name private object should be taken as another object name, and two variables here we have taken public static void string and object parameter. So name variable that is the string, this dot object we have created, that is the object. Public string get name return name we have taken public. uh, Object get object return object, so that we need to consider in the past. So this is the one way of the approach what we have to. So actually here what we say that, so actually each command has an associated object that stores the which is the data is needed to undo it. The class which correspond to the operations uh, for adding a line which can be shown in the next slide. So that we say that adding a line, we have the class line object line, again get line method will be taken. So when operations for adding this line completed, the stack object will be taken. Similarly, public class controller that we have taken class history of, and decoding simply matter popping the stack reading string. So but finally undoing simply we say that line object, delete object, uh, select object. So finally undoing is simply a matter of retrieving the reference to and removing the line from the model. So this is the actually there are will get a drawback of this one. There are two obvious drawbacks of this approach. Whenever we had a line object, we have this, so that pushed into the stack format line, decoding that, popping the stack, reading the point, like undoing object, line object equal whatever we have taken that equals. So there are two drawbacks of each. So there is a one drawback is the long conditional statement in the undo method of the controller, and other one drawback is the need to rewrite the controller whenever we make changes such as adding or modifying the implementation of an operation. So we say that particular operations. So this we could representing a drawing line. So before that we should discuss about how these issues can be resolved. So what is the drawback actually? The object oriented approach dealing with the first drawback to a subclass having inheritance hierarchy actually come to the first conditional statement undoing method of the controller. So where we can do the replace conditional logic with polymorphism. So that is the we can resolve that kind of drawback. How we can do that? So that is the one small code we have not taken here. Simply class controller will be stack object of our extract that what we have taken here. Class controller stack history is required, so which will be stored all the details. Stack object undoing object history dot all history will be pop up. So that we have to call the respective methodology also for this one. Again public class stack object void undo controller class, okay, object and get object name that could be taken. A name equals line controller undo line object, else name equals delete controller undo delete or delete object will be taken, else if name equals in select, so that could be taken. So here actually in our conditional stack object that we are we say that we are ready to subclass this behavior. So hierarchically we will have a subclass corresponding to the each operations. For example, representing we had discussed in the below figure that one, to represent drawing a line we have the class line object as a subclass of the stack object. So this is we have the stack object and respective of the line object. Subclass is the line object with the method is here line and line object undoing controller void. So this extends controller undo line of this object. So this pointer will have to be taken because extendable class. So here note that we should decode the stored object there the name of the field which are not required. So the make line method which used here, whatever that one, the method which is simplified, it just creates the line object and pushed into the stack. So this is the representation of a drawing line. So now let us discuss the employing the command pattern. So actually what is the meaning of employing the command pattern? Here the stack object, example line object which passes itself as a reference which double dispatch. So in the command prompt. So one last thing that so we could discuss about command pattern, the intent of command pattern. So encapsulate a request as an object, thereby letting uh, parameterize the client with different requests. So queue or log request and support undoable operations. So we have partially which satisfied in this content. So a scenario of the line object with the separation. So for instance, we can execute operation create a line object which are pushed into the stack. We have failed to require so far. That could be a command, undo, boolean, redo, boolean, execute, return type is void. So these we could take it as the repository of associate data, but can also encapsulate the routine that need to access the data. The command pattern provides us with a template to address this. The abstract command class, abstract method to execute, undo, or redo it. So this we could take it in the sequence diagram for adding a line. So how that we are going to take it? This is the mechanism best explained via an example which we developed somewhat simplified a sequence diagram for the command to add a line. So this is the we are already familiar with uh, sequence diagram. This is the actor and rest all the system responses. So view class, undo manager class and model class will be created here. This is the timeline process. Actor and actor will be replay that response from the shifter. So this is the create line. So the point 1, point 2 will be taken because add a line will start with left hand point to the right hand point. So whatever it is. So create line point 1 here, create line command we are using directly. So because of an undo manager will create a line of that one. So that will be created in the model. Begin command, line command which execute add line method. So we'll get the acknowledgement is the 1 point line add line method is started. So point 2 set line point again will be coming to the undo manager in the timeline process set point 2. So that is again add line method will be connected. So end point. So that is the return type is the point 2 is the end point. So end command line command end point will be taken. So set change in the model. So starting point to the end point. So these respective refresh command will be used. So acknowledgement to the view is the rendering that object line is created. So create a line, this is the adding line part 1. So this line is undo manager will give the message line is created from to the vector. So this is the what we have draw line command is instant a line command will be taken here. Majorly we need to notice that one the central idea behind this command pattern. So because we use the line command here, command pattern is to employ the two stack, one for storing the command that can be undone history stack, and other is maintaining the command that redo stack here line that we have taken redo stack. The class undo manager here, undo manager, the undo manager plays a role for the controller because we had not taken here controller view class, controller class, model class, but instead of control class we have taken because undo manager is a role for the controller classes. So that we have taken, but we have given a new name highlight that maintains the particular function. So begin command we have taken here method here, and end command are two purposes. One is the execution purpose begin command, the undo manager ensures the line object get added to the respective model. Similarly this way we need to refresh that one. So partially the line will be shown on the screen. So like that here. So we could take add label and draw circle, add a label or draw line, so that we can be taken into the point. undoing an operation. So continuing with the above example, now we look at the sequence actions of undo request is issued immediately after the line 1, which has been completely drawn in the above sequence diagram. So what we can conclude here, which has been completely drawn in the above sequence. So user views the command is undone if the line disappears from the screen. This thing, for this the line object must be removed from the collection to be consistent with this action and to allow the redoing the operations. So that we need to take it as the in the next slide, status of the stacks and the collection in the model. So here what we said, not every command is undoable. So the general rule is that when the undo operation is requested, if the top of the undo stack is a command that can be undone or undoable, the command is undone and transferred to the redo stack. So in this diagram, so the line command object must be popped from the history stack, okay, line command here, and pushed onto the redo, so most recent command, redo stack. The resulting configuration which we have shown in this diagrammatical representation of the next figure. So in this diagram, so what we are going to see here, the redo stack empty since no command have been undone. There is redo, there is a nothing to redo. The picture also shows that collection of object in the model storing the two label object, circle object, or we say that a line object. So here we say that a line object, label object, circle object, and will be taken history stack, and redo stack, which is always an empty collection in the model. So line 1, line 2, line 2, or label 2. So in the next slide, so this is the way what we said, post history stack and pushed onto the redo. So that we have taken into this line 2 object, more recent command. So line 2 of the previous command and redo stack of the line 1 collection in the particular model. So here the redo operation is simpler enough. If the redo stack is not empty, the command must be re-executed and top of the object a redo stack must transferred to the history stack. The redo involves updating model like the redo method of the command object calls execute method to do the necessary actions. For the line command object, which involves adding the line back to the model of the collection. So here we noted that what we said, not every command may be undoable. So at least is not worth the trouble. So if an undoable operation is on the undo stack, the undo cannot proceed beyond the operations. So here, although we say that undoable operation is underneath in the stack, to get around this problem, we might choose an not post undoable command onto the stack. So this is, we say that this is accomplished by making command itself. So assume the responsibility for pushing on the history stack. So like that, so we will continue in the next videos. Again, status of the stack and collection in the model after undo and its implementation, undo manager, and so and so.